Welcome to another lecture. So our lesson targets for this lecture is you will be able to explain or understand the encapsulation and the de-encapsulation process used by routers when switching packets. We will also examine how a router builds a routing table using static routes. You will have an example of how to use and configure a static route. We'll also examine how a router builds a routing table using a dynamic routing protocol. So in a router, when a packet arrives at the router and needs to be forwarded to another network, the router performs the de-encapsulation and encapsulation as part of the process. This will be done upon the entry of the packet, the data packet, into the router. So the first step will be done is the de-encapsulation. This is the removing of the old information from the packet that just arrived to the router. So when the router receives a frame, there is extra information like the MAC address of the source, MAC address of the destination. So the router will remove the old layer 2 data link information, and this includes the source MAC address and the destination MAC address. Now the router just sees the IP packet layer. This is the IP packet layer. This is layer 3. The next step is the routing decision. The router reads the destination IP address in the packet, and then it uses the routing table to decide which interface and next hop to send the packet to. So this was the this was the strip of packet. You can already see the router can see the source IP address, the destination IP address. With this data, with this information, the router can then determine where to forward the data frame based on its routing table. So let's say this is the appropriate route to this destination. Then the router will use this part of the routing table to forward the next to the next router. After adding new information, the router then adds new layer 2 information like the source MAC address and the destination MAC address of the next router or the next hop router. And then the new frame is sent out to the next router or destination. So that is how the encapsulation and encapsulation works. So in simple analogy, think of the packet as a letter inside an envelope. So let's say when it is the encapsulation process, it's like opening the old envelope. The routing process, this is when it is you or the person is reading the address on the letter. So there will be two. If we are talking about a letter, where will the letter be forwarded to? And then when it is the process of the encapsulation, this is comparable to putting the letter into a new envelope with the next destination address. Okay, so that is just a simple analogy on how the encapsulation and encapsulation process. So when we talk about routing, it is always looking for the best and shortest path from point A to point B. So this is almost always the main objective, the main purpose, the main use of routing, of a router. A router should have a routing table. But how do a router acquire a routing table? So there are two processes. The administrator can manually input into the routing table using static routes. These static routes do not update automatically. They require reconfiguration when there are changes to the network topology. If there will be broken paths, if there will be new paths to the destination, then the network administrator must configure these new routes. Another way of acquiring a route table, a routing table, is through the automatic acquisition through dynamic routing protocols. So we will learn these two methods on how to acquire a routing table for a router. So here are some comparisons of the dynamic and static routing. The complexity in configuring these both types of routing. In dynamic, this is generally independent of the network size, while in static, the routing table will increase if the network size will increase. So if there will be multiple paths, multiple destinations, then if you're using static routing, then there could be multiple routes, multiple configurations. It will add to the burden of the network administrator because he or she will need to manually configure the static routes. When the topology changes in dynamic routing, it automatically adapts to topology changes. While in static routing, the network administrator needs to actually reconfigure the static route. So let's say this is point B and point A, and then this is C. So the best path from A to C is this one. But what if there is a problem in this best path? So the administrator must reconfigure and add another static route from here to here. Scaling. In dynamic routing, this is suitable for simple and complex topologies, while in static routing, this is suitable for simple topologies. Okay. Security. In dynamic routing, this is less secure, while in static routing, this is more secure. Why is it so? The administrator is the one who is configuring the static routes. He or she is the one who configures the path from A to C or the path from A, B, C. If this router is using the dynamic routing, router will just learn or automatically determine, this is the best path from A to C. This is the best path from A to B. Or this is the best path from A to C, ADC. What if this D is a malicious entity? What if this router D is just a bogus router meant to get the information from A to C? So how did the router A get the routes when using dynamic routing? Routers advertise themselves. Sends broadcast. Yes, the word is advertise. It sends broadcast to other routers that, hey, I'm available. I'm the best path from D to C. Hey, I'm available. I'm the best path from your router to the C router. So that is why dynamic routing is less secure. In dynamic routing, it uses CPU, memory, and link bandwidth. This is once again due to the advertisements or the broadcast of messages that this, hey, next router, I am alive. Hey, next router, I am alive. Hey, this is the router. I need you. You're the best path from A to Z. While in static routing, there are no extra resources needed because the network administrator has already configured the routes. Predictability, when speaking of dynamic routing, the route depends on the current topology. If you have multiple paths from A to D, if this breaks, router A will choose another path. This one or this one. If this breaks, both of them breaks, router A will choose the best path. In static routing, router A will always use the same path from A to D. If this breaks, the network administrator will reconfigure the router and add another path. And another path. If this breaks, router can add another path. So static routing is a protocol that helps to keep your network organized and to optimize routing performance. This enables the router to assign a specific path to each network segment. Let's say from A to B, this is the only path. This is the specific path. Static routing can keep track of the network changes because if there is something wrong with this path, then this path is not unusable. It also helps to improve network stability and continuity. The network administrator can always determine this path is still working. This path is still good. Just tell me if you need another path and I will configure another path. because the network administrator knows and is the only one who configures the routes, then static routes are considered secure routing. So the usage of static routing, these are smaller networks that are not expected to grow, could also be a single default route to represent a path to any network not found in the routing table. You could also configure a static route as a secondary route as a failover mechanism in the event that the primary route will have a link failure or there's problems between A to B. So the network administrator can add another route as a backup route. So these are the types of static routes. First is standard static route. These are manually configured route that is explicitly defined in the router's routing table. This specifies a fixed next hop IP address, meaning if you want to access this network C from A, this is the best path, and the IP address of the router is the next hop IP address. In a default static route, this is manually configured route that is used by a router to forward packets for any destination that is not explicitly defined in the routing table. So let's say A needs a network or needs a connection from A to B, but it is not found in its routing table. But the network administrator has already configured a default static route, in which if this routing table does not coincides with this configuration, I mean destination, then we will use this default route that is found on the routing table. So the router uses this routing table entry to forward it to the next hop IP address. This is utilized when a packet does not match any specific route in the routing table. Another type of static route is a summary static route. This is a manually configured route that summarizes multiple routes into a single route entry into the routing table. Let's say these are your routing table entries. And this entry is the destination. All the destination of this entry are all going to router B. So routing table can be configured to use another entry wherein all these routes can be configured into one single route. So it summarizes all these entries into one single entry. This will reduce the size of the routing table. Instead, here in this example, 1, 2, 3, 4, 5 routes, we can compress it into one route only. A floating static route is a backup route that is configured with a higher administrative distance than the primary route. So let's say we can transfer this one, primary route number 1, to the top, so that every time when when the router requests a routing table for the best path from point B, this is the first entry that will be processed in the routing table. This is used to provide redundancy in case the primary route fails, and these are the types of static routes. So when you want to configure static routing in a Cisco router, this is the command: IP space route, the destination network address, subnet mask, and then the next hop IP address. Let's say, for example, this is an example command: IP space route. This is the destination network address. This is subnet mask. And then this is the next hop IP address. This is the diagram of the command, that this example command. So this IP route command, this network wants to access this network. So this command will ensure that the configuration that will be done will access this destination network, its subnet mask, and then this is the next hop IP address. From this network, what is the IP address directly connected to the source network? So this is the next hop IP address. So with just one command, you can essentially create a static route from point A to point B. If you want to determine your routing table, specifically the static routes, you can use this command: show IP route static. This will verify the static routes configured in the device or in the router, and this will show the static routes that are defined currently in the router. So that's all. If you have any questions, feel free to contact me in any means that you deem, in any means that you want. Thank you and have a nice day. Goodbye.